Meet Maya. She just volunteered to help her school's fundraiser committee, and they need someone to analyze the donation data. There are 12 different donation amounts, all jumbled up, and Maya has no idea where to start. Sound familiar? Today, we're going on Maya's journey, from confused to completely confident, as we unlock the 4 most powerful tools in statistics: mean, median, mode, and range. Let's go. So Maya sits down with her fundraiser list and thinks, okay, I have all these numbers, but what do they actually tell me? That's exactly the question Measures of Center answer. They give us one number that summarizes a whole set of data. Think of it like a team captain, one person who represents the whole group. We have 4 tools: the mean, the median, the mode, and the range. Each one tells us something slightly different, and together they paint the full picture. Here is Maya's donation list from the school fundraiser. 8 students each collected donations, and the amounts in dollars are 4, 7, 7, 9, 11, 13, 15, and 18. Maya writes them all down in a row. Before we do anything else, notice something important. She arranged them from smallest to largest. That's called putting data in order, and it's the very first step before finding median or mode. Always sort your data first. It makes everything easier. First up, the mean. The mean is what most people call the average. Here's the recipe. Add all the values together, then divide by how many values there are. Maya adds her 8 donations: 4 plus 7 plus 7 plus 9 plus 11 plus 13 plus 15 plus 18. Let's add step by step. 4 plus 7 is 11, plus 7 is 18, plus 9 is 27, plus 11 is 38, plus 13 is 51, plus 15 is 66, plus 18 is 84. Now divide 84 by 8. That gives us 10.5. The mean donation is $10.50. Next is the median, the middle value. Maya already has her data in order: 4, 7, 7, 9, 11, 13, 15, 18. Now she crosses off one number from each end, like peeling an onion. Cross off 4 and 18. Cross off 7 and 15. Cross off 7 and 13. Now we're left with 9 and 11. Uh-oh, 2 numbers. When there's an even number of data points, we find the mean of those 2 middle numbers. 9 plus 11 is 20. Divided by 2 is 10. The median is 10. 2 more to go. The mode is the value that appears most often. Maya scans her sorted list: 4, 7, 7, 9, 11, 13, 15, 18. Which number shows up more than once? 7. It appears twice, while every other number appears just once. So the mode is 7. Now the range. This tells us how spread out the data is. Subtract the smallest value from the largest. 18 minus 4 equals 14. The range is $14. Maya is crushing it. She's found all 4 measures. Just like a problem Maya might see on her math test, here are 5 test scores: 72, 85, 90, 85, and 68. First, let's sort them from least to greatest: 68, 72, 85, 85, 90. Now the mean. Add them up. 68 plus 72 is 140, plus 85 is 225, plus 85 is 310, plus 90 is 400. Divide 400 by 5, that's 80. Mean equals 80. Median. With 5 values, the middle one is the third. That's 85. Mode. 85 appears twice, so mode equals 85. Range. 90 minus 68 equals 22. Here's a fun twist. What if there's no mode? Check out this set of numbers: 3, 8, 12, 5, and 10. Sorted: 3, 5, 8, 10, 12. For the mean, 3 plus 5 is 8, plus 8 is 16, plus 10 is 26, plus 12 is 38. Divide 38 by 5, that's 7.6. Median, 5 values, so the middle is the third number. That's 8. Mode, every number appears exactly once. There is no mode. That's totally valid. Range, 12 minus 3 equals 9. See, sometimes the answer is no mode, and that's perfectly correct. Now Maya discovers something surprising. Data can have two modes. Look at the set: 6, 9, 6, 14, 9, 11. Sorted: 6, 6, 9, 9, 11, 14. Mean: 6 plus 6 is 12, plus 9 is 21, plus 9 is 30, plus 11 is 41, plus 14 is 55. Divide 55 by 6. That's approximately 9.17. Median: 6 values, so average the third and fourth, 9 and 9. 9 plus 9 is 18, divided by 2 is 9. Median equals 9. Mode: both 6 and 9 each appear twice, so we have two modes. This is called bimodal data. Range: 14 minus 6 equals 8. Here's a question Maya asked that stumped even her teacher at first. When should you use the mean versus the median? Great question. The mean works beautifully when data is fairly balanced. But watch what happens with an outlier, a number that's way bigger or smaller than the rest. Imagine one student donated $100 instead of 18. Suddenly, the mean jumps way up, but the median barely changes. That's why news reporters often say median household income instead of mean. The median is more resistant to extreme values. Maya's committee wants a final report. Let's pull it all together using her original donation data one more time. 4, 7, 7, 9, 11, 13, 15, 18. She writes her summary. Mean equals $10.5, the average donation per student. Median equals $10, the middle of the data. Mode equals $7, the most common donation amount. Range equals $14, showing the spread from the smallest to largest gift. Maya presents this to her committee, and they're seriously impressed. She just turned a messy list of numbers into a clear, meaningful story. Before we wrap up, here are Maya's favorite memory tricks so you never mix these up. For mean, think mean sounds like machine, a machine that does a lot of work adding and dividing. For median, think of the median strip in the middle of a highway. It's always in the center. For mode, mode and most both start with the letter MO, the most frequent value. And range, think of a mountain range stretching from the lowest valley to the highest peak. That's the spread. Remember when Maya stared at that messy donation list, totally overwhelmed? Look at her now. She walked in with 12 random numbers and walked out with a complete statistical report. And you just did the same thing. Here's your quick recap. Mean, add everything, divide by the count. Median, sort the data, find the middle. Mode, the value that appears most often, could be none or 2 or more. Range, largest minus smallest. You've just leveled up your math game. These 4 tools will follow you through middle school, high school, and beyond. Go show someone